The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are 3 different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I will respond as soon as I can. All right, a couple of things. First of all, yesterday when I rattled off the schedule this week, I forgot about chapter 5. So I think I said yesterday we were going to look at chapter 8 today. We're actually going to start with chapter 5. If we get through chapter 5, we'll start chapter 8, but we'll wait and see. The other thing is that I want to actually do one more problem concerning graphing inequalities. Okay, can everybody see my WebAssign screen with the grid there of a graph? Somebody just tell me yes or no. Come on, somebody.
Yes.
Yes, thank you. All right, so I just wanted to review this process because I know some of you just still never figured it out. So you're going to graph an inequality, and I'm not going to come up with a specific inequality. I'm just going to say, okay, we're graphing an inequality. All right. So the first thing we need to get the line, and we need to double click on it to where this is blue. We don't want to choose this because that's a ray and this is a line segment. So we definitely want a line. Okay, then we want to plot 2 points on the graph. So depending on which way you went about it, looking at yesterday, if you use slope intercept form, maybe you've got a y-intercept, and then let's say the slope is -2/3. So here would be your second point, okay? Or if instead of doing it that way, you found 2 points, maybe you plot a point and then another point. Okay, so in any case, now you've got a line. Then there's 2 other things you've got to consider. You've got to decide whether it's a solid line or a dotted line. Let's say that it's a solid line, we're good to go. But let's say it's a dotted line. You'd come over here and where it says dashed, you would click it. Now it's a dashed line, dotted, dashed, same thing. And then you need to choose which side of the line you're on. Let's say it's above the line. Okay, we're going to click on fill and then click above the line. So there you have your graph. Any questions on that before we go on to chapter 5? Okay, so now let's go back here and take a look here. So in chapter 5, we started on section 5.4. So I want to look at that. Section 5.4 involved identifying whether something was a monomial, a binomial, a trinomial, or just a polynomial in general. A monomial has 1 term. A binomial has 2 terms. A trinomial has 3 terms. These are all considered to be polynomials, which means many terms. When there's 4 or more terms, we just call it a polynomial. All right. Any questions about that? So let's talk about coefficients and variables, etc., etc. So this monomial is a 2nd degree monomial because of the 2 on the variable, the exponent on the variable. It has a coefficient of 3. This binomial has 2 terms. The first term is of degree 2 and has a coefficient of 2. The second term is of degree 1 and has a coefficient of 3. This is also a 2nd degree polynomial. The degree of the polynomial is the same as the degree of the highest powered term, not the sum of all the variable exponents. Okay. And finally, here's a trinomial. The leading term is -7x squared. It's of degree 2. The coefficient is -7. The second term is 4y. It's of degree 1, and the coefficient is 4. The third term is of degree 0 because there's no variables, so it'd be like y to the 0 power, and the coefficient is -18. All right, let's say we had 4x squared y cubed plus 8. This is a binomial. The degree of the first term is 5. The degree of the second term is 0. So this would be a 5th degree binomial. Any questions about that? All right, let's do evaluating an expression. Let's say we have the following expression, x cubed minus 3x squared minus x plus 9. And we're going to evaluate this for x equals -3. So every place that x appears in the original problem, we're going to replace it with a -3. So this would become -3, the quantity cubed, minus 3 times -3 squared, minus -3 plus 9. Lots of 3's and -3's there. Okay, now simplifying this first term, -3 times -3 times -3 would be -27. Then we have minus 3 times. -3 times -3 is +9. Minus a -3 becomes plus a +3 and then plus 9. Continuing on, we have -27 minus 27 more plus 3 plus 9. -54 plus 3 plus 9, -51 plus 9, -42. Is that right? Okay, so there's our final answer. Any questions about that? Alrighty, that takes us to section 5.5, adding and subtracting polynomials. So let's see here. If we've got something like this, 15x squared plus 10x squared. This is a binomial, but these are like terms. So combining like terms, we could simplify it down to a monomial. Its coefficient is 25, and it is of degree 2 because of the 2 exponent on the variable. Let's see here. 17y squared minus 22y minus y squared. Simplifying this polynomial, we would combine those two like terms. 17y squared minus 1y squared would be 16y squared minus 22y. Okay, let's say we've got, how about this one? 5b minus 9ab squared plus 10a cubed b minus 8ab squared minus 9a cubed b. Combining like terms, these would go together and these would go together. I'm going to write the final answer in descending powers of the variable a. All right, so a cubed would be first. 10a cubed b minus 9a cubed b would be 1a cubed b. The coefficient of a 1 is implied in front, so I don't need to write it. Then I'm going to put, let's see, my next highest power of a would be just plain old a to the first power. Minus 9ab squared minus 8ab squared would be minus 17ab squared. And then finally, plus 5b. Our final answer is a trinomial of degree 4. Where am I getting the 4? Don't forget there's an implied 1 there, an implied 1 there. So this term is of degree 4, this term is of degree 3, and this term is of degree 1. So the highest powered term would be 4, so the entire polynomial is 4th degree. Okay, let's see here. Let's say we've got something like this. The quantity 3a squared minus 2a plus 4 minus the quantity a squared minus 3a plus 7. When there's either nothing or just an implied 1 in front of a grouping symbol, we can just distribute that implied 1, which in effect gets rid of the grouping symbol. So we rewrite it without the parentheses. If we have a subtraction sign in front of a grouping symbol, we distribute it to each term inside the grouping symbol, which gives us minus a squared. Minus times minus is plus 3a. Minus times plus is minus 7. Once we've broken down all the grouping symbols, now we can combine like terms. 3a squared minus 1a squared is 2a squared. Minus 2a plus 3a would be plus 1a, and 4 minus 7 would be minus 3. So we end up with a trinomial of degree 2. Alrighty, let's see here. Any questions on that example? Okay, let's go on to section 5.6. 5.6 is multiplying polynomials together. If we have something like this, negative 2a cubed times 11a squared. Well, let's see here. We could rearrange that as negative 2 times 11 times a cubed times a squared, which would be negative 22 a to the 5th power. We could go straight there from the top problem, but just showing how things get put together there. All right. If we have, let's see here, negative 5 x cubed y to the 6th power times 2x squared y squared, that would be negative 10 x to the 5th y to the 8th power. Any questions about that? Okay, let's say we're multiplying a monomial by a polynomial. We're going to distribute, so we're going to get negative 8b to the 5th power plus 8b to the 4th power minus 8b cubed. All righty, and again, if you have any questions, please stop me. Otherwise, I'll just keep going here. Now let's multiply a polynomial, that is a binomial, times a binomial. So we're going to FOIL this together. We'll do the first times the first, then we'll do the outer, and then the inner, and then the last. Combining like terms, we get y squared plus 8y plus 15. Let's see. What if we've got 5x minus 3 times 2x minus 3? We get 10x squared minus 15x minus 6x plus 9. Combining like terms, 10x squared minus 21x plus 9. Any questions there? All righty. Let's see here. Let's say we've got a binomial times a trinomial. We take each term in the first binomial times each term in the second trinomial. So we get x times x squared, which is x cubed, x times minus 2x, which is minus 2x squared, x times 3, which is 3x. Then we move to the next term. 2 times x squared is 2x squared. 2 times minus 2x is minus 4x. and 2 times 3 is 6. Combining like terms, we get x cubed. These would cancel, minus x plus 6. So there's the final answer there. Okay. Any questions there? All right, let's say we've got something like this. 5a times 3a minus 2 times 2a plus 3. We can only multiply two of these things together at a time. So I'm going to start at the beginning and get 15a squared minus 10a. Then I'll take that times 2a plus 3, which gives me 30a cubed plus 45a squared minus 20a squared minus 30a. Combining like terms, 30a cubed plus 25a squared minus 30a. Okay, here. Let's see. Let's take a look at this problem. Let's contrast this. -5 r to the 4th t to the 2nd minus 2 r squared t. And that compared to -5 r to the 4th t squared times 2r squared t. Well, on the first example here, we're adding or subtracting. We can only do that with like terms. These are not like terms, so our final answer, we couldn't really do anything to simplify this problem other than write it without the parentheses. The second problem, we're multiplying, so here we would get -10 r to the 6th t to the 3rd power. So be careful of the operations. It changes how you go about doing things. Okay, let's see, how are we doing for time? We're doing just fine. Let's take a look at 5.7, which is special products. So let's say we've got something like this. A common mistake is to write that, which is wrong. What you've got to do is you've got to say, well, I've got 2 factors of y plus 7, and then we FOIL them together. So we get y squared plus 7y plus 7y plus 49, which is y squared plus 14y plus 49. The reason that people tend to make this mistake is that if you had 7y, the quantity squared, where inside it's a product, this would be 7 squared y squared or 49y squared. But if you've got y plus 7, this is not a product inside, so you can't just take that 2 and attach it to each of the terms inside. You've got to expand it out, FOIL it out, etc. Okay, so be careful of that common mistake. Also, let's go back to this again. And we got what? Y squared plus 14y plus 49. This is called a perfect square trinomial because it has 2 identical factors. All right, now suppose we've got something like this: y plus 6 times y minus 6. And we FOIL this together. We get y squared minus 6y plus 6y minus 36. But when we combine like terms, the 2 middle terms cancel out, and we end up with y squared minus 36. In general, if we're adding the same two terms and then subtracting the same two terms, and we're foiling the two binomials together, the middle terms cancel out and we get what is called the difference, as in subtraction, of two squares. This is the difference of what? Y squared minus 6 squared. We would write it like this, but it still is the difference of two terms, both of which are squares. Okay. Now, let's say we've got something like this, y plus 2, the quantity cubed. Again, this is not y cubed plus 2 cubed. It's y plus 2 times y plus 2 times y plus 2. So we've got to FOIL two of them together at a time. Let's do the first two first. So this becomes y squared plus 2y plus 2y plus 4. All of that times y plus 2 times that last factor. But then let's combine like terms. Y squared plus, plus 4y plus 4, all times y plus 2. So now we'll continue multiplying and we get y cubed plus 2y squared plus 4y squared plus 8y plus 4y plus 8. So we're multiplying each term in the trinomial times each term in the binomial. Combining like terms, y cubed plus 6y squared plus 12y plus 8. So there's your final answer in descending powers or standard form. So this would be a polynomial of degree 3. The leading coefficient would be an implied 1. Okay, let's see here. Let's take a look at a fraction. Let's say we've got the quantity q to the 6th power plus 1/3 squared. That would be q to the 6th power plus 1/3 times q to the 6th power plus 1/3. So we expand it. Now foiling it, we would get q to the 12th power plus 1/3 q to the 6th power plus 1/3 q to the 6th power plus 1/3 times 1/3, which is 1/9. Remember, we're multiplying. Combining like terms, we get q to the 12th power plus, well, 1/3 plus 1/3 is 2/3, q to the 6th power plus 1/9. Alrighty. And with that, we'll go on to section 5.8, which is dividing polynomials. So first of all, let's look at dividing a monomial by a monomial. Let's say we've got a to the 12th power divided by a to the 8th power. When you are dividing two powers with the same base, you take the base and you take the top exponent minus the bottom exponent attached to that base. So this becomes a to the 4th power. Let's say you've got 22b to the 9th power divided by 6b to the 6th power. 22 over 6, we can take a 2 out and reduce it to 11 over 3. B to the 9th over b to the 6th would be b to the 3rd. So we can write it as 11/3 b cubed or 11b cubed over 3. Either way. Let's let's see here. Let's say we've got 3y cubed z over 18y z to the 6th power. Well, 3 over 18 reduces to 1 over 6. Y cubed over y would be y squared on top. Z over z to the 6th. Well, that's like z to the 1 power over z to the 6th, which would be z to the 1 minus 6, or z to the negative 5 power. But we can take a number raised or a variable raised to a negative exponent, if it's a factor, move it to the denominator and change the sign of the exponent. So now I've got this, and I could write this as 1/6 y squared over z to the 5th, or I could write it y squared over 6z to the 5th. Okay. All right, let's see here. Now, let's say we've got a polynomial divided by a monomial, like 8x plus 4 over 4. If you have a polynomial divided by a monomial, the process is to take each term of the numerator and divide it by the denominator. I feel like I'm traveling at the speed of light here, trying to get through all of this. Again, if you need me to slow down or you have any questions, please stop me. So now we're going to reduce each separate fraction. 8 over 4 would be 2 over 1, so we get 2x plus 1 would be our final answer. Let's say we've got 4x to the 14th minus 36x to the 8th power, all over 36x to the 12th power. We have a polynomial divided by a monomial. So we take each term in the numerator and divide it by the term in the denominator. Then we go back and simplify each separate fraction. So here, let's see, 4 over 36 is 1 over 9. X to the 14th over x to the 12th is x squared, so we get 1/9 x squared, or you could write it as x squared over 9, either way, minus the 36's reduce out, but x to the 8th over x to the 12th would be x to the 8 minus 12, which is x to the negative 4, or 1 over x to the 4th. So you could write it like that or like that. You don't want to leave it with a negative exponent unless it says to. Okay. Let's see here. Let's take a look at one more of these. 12 r to the 15th power minus 48 r to the 12th power plus r to the 10th power minus 18 r to the 8th power, all over 6 r to the 10th power. So again, we have a polynomial divided by a monomial. So we take each term in the numerator and divide it by the term in the denominator. And then we go back and reduce each separate fraction. 12 over 6 reduces to 2 over 1. R to the 15th over r to the 10th would be r to the 5th on top. 2r to the 5th over 1 reduces down to 2r to the 5th. Minus 48 over 6 is 8 over 1. r to the 12th over r to the 10th is r squared. That reduces down to 8r squared. Plus r to the 10th over r to the 10th is 1 over 1. So we've got plus 1 over 6. And then minus 18 over 6 is 3 over 1. R to the 8th over R to the 10th would be R to the negative 2, which would be R squared in the denominator, moving it downstairs, changing the sign of the exponent. So there is your final answer. All right, now we're going to look at dividing a polynomial by a polynomial. So let's say it says to divide x squared plus 8x plus 12 by x plus 2. So the x plus 2 is the divisor. It goes on the outside. The x squared plus 8x plus 12 is the dividend. It goes on the inside. We want the dividend and the divisor to both be in descending powers of the variable. In this case, they already are. So then we start by focusing on the leading term inside and the leading term outside. We take the leading term inside divided by the leading term outside. X squared divided by x is x. So we put that up on top. Then we take this times all of that. So we've got x times x plus 2, which is x squared plus 2x, which we write down below here. Then we draw a line. We're going to subtract that entire polynomial, subtract the x squared plus 2x from that which is above it. Now we're going to distribute the subtraction sign by changing it to addition of the opposite. So it becomes a plus sign, and the sign of each term inside the parentheses changes. Now that I'm adding, I can ignore the parentheses and just add the columns. X squared plus negative x squared is 0x squared, so nothing there. 8x plus negative 2x would be 6x. Bring down the next term and start the process over, focusing on the leading term inside and the leading term outside. 6x divided by x is 6. That's a positive 6, so we're going to write plus 6. Then we're going to take this times all of this. So 6 times x plus 2. Distributing, we get 6x plus 12, which again we write there. Draw a line. We subtract that from what's up above. Distributing the subtraction sign, changing it to addition of the opposite, we get 0 and 0. So there's no remainder. So x squared plus 8x plus 12 divided by x plus 2, the answer is x plus 6. You could check your work by multiplying x plus 6 times x plus 2, x squared plus 2x plus 6x minus 12, x squared plus 8x minus 12, and that, oh, not minus, it should have been plus 12. So it checks. So my correct answer is x plus 6. All right, let's take a look at another example. It says 4x squared plus 6x minus 1 divided by 2x plus 1. So the 2x plus 1 goes on the outside, the divisor. The 4x squared plus 6x minus 1 goes on the inside, the dividend. Again, they are both in descending powers. So focusing on the leading term inside and the leading term outside, 4x squared divided by 2x would be 2x. So that goes up in the x column. Then we're going to take 2x times 2x plus 1. That is this times this. Distributing, we get 4x squared plus 2x, which we write here. Okay. We're going to subtract that quantity from what's up above, change it to addition of the opposite. 4x squared plus negative 4x squared is 0x squared. 6x plus negative 2x is 4x. Bring down the next term and continue. We're going to focus on the leading term inside divided by the leading term outside. 4x divided by 2x is plus 2. Then taking 2 times the quantity 2x plus 1, 4x plus 2, 4x plus 2. We're going to subtract that quantity from what's up above. We'll change it to addition of the opposite. We get 0. Negative 1 plus negative 2 is negative 3. So now we have a remainder. So our answer is going to be 2x plus 2 plus the fraction, oops, negative 3 over 2x plus 1. Okay. Any questions about that example? All right. Let's say we've got this problem. X plus 3 divided into negative x plus 2x squared minus 21. Well, the problem here is the dividend inside is not in descending powers. So I'm going to rewrite that. The outside's fine, but the inside should be 2x squared minus x minus 21. So we're going to reverse the order of those two terms because they're not in descending powers. Now we'll carry on as before. 2x squared divided by x. 2x squared divided by x is 2x. 2x times x plus 3 is 2x squared plus 6x. 2x squared plus 6x. We'll subtract that from what's up above, change it to addition of the opposite. 2x squared plus negative 2x squared is 0. Negative x plus negative 6x is negative 7x minus 21. Again, we're going to focus on the leading term inside and the leading term outside. We've got negative 7x divided by x, which would be negative 7. So we're going to write minus 7 up there. Minus 7 or negative 7 times x plus 3, negative 7x minus 21, which we write there. Subtract that from what's up above. I can't talk. Change it to addition of the opposite, and we get 0. So there's no remainder. So the final answer for this problem is 2x minus 7. Okay, let's see here. Now, suppose we've got something like this. A squared minus 25 divided by a plus 5. So we'd have an a plus 5 outside and a squared minus 25 inside. And going on, we focus on the leading term inside divided by the leading term outside, and we get a, we'll just put that up there. Then a times a plus 5 is a squared plus 5a, a squared plus 5a. We're going to subtract that, change it to addition of the opposite. We get 0x squared, but these aren't like terms. Things are kind of messy. So what we're going to do is this. Outside, we've got a plus 5. Inside, we've got a squared. We're going to put in a 0a as a placeholder. So I've got a squared. I've got no a's to the first power, but I'm going to put a 0 in there, and then minus 25. Much like if you wrote the number 408, you wouldn't write it like that, and you wouldn't write it like that. You'd write it like that. You'd put a 0 as a placeholder, as if to say 4 hundreds, no 10s, and 8 1s. All right, so we've got that placeholder. Now going back and focusing on the leading term divided by the leading term, we get a, and it goes in that column where the a's are. And we take a times a plus 5. Again, I want to focus on 0a has no value, so we haven't changed the problem. We've just created a column to put the a terms in. Okay, so this becomes a squared plus 5a. We're going to subtract that from what's up above, change it to addition of the opposite. We get 0a squared. 0a plus negative 5a is negative 5a. Bring down the next term, minus 25. And then we've got, let's see here, negative 5a divided by a is negative 5. And negative 5 times a plus 5 is negative 5a minus 25, which we write there. Subtract it from what's up above, change it to addition of the opposite, and we get 0, which means our final answer is a minus 5. And let's see here. How about this one? Y cubed plus 8 divided by y plus 2. So outside I've got y plus 2. Inside I've got y cubed plus 0y squared plus 0y plus 8. Again, all of the missing powers need to be represented. I've got y cubed, but I need to have a column for the y squared and a column for the y, and then my column for my constant 8. So now the leading term inside divided by the leading term outside gives me y squared. Y squared times y plus 2, y cubed plus 2y squared, y cubed plus 2y squared. Okay, I'm going to subtract that quantity from what's up above, change it to addition of the opposite. We get 0 y cubed, and then 0y squared plus negative 2y squared is negative 2y squared. I'll bring down the next term, the 0y. Start over. We're going to focus on the leading term on the inside divided by the leading term on the outside. Negative 2y squared divided by y is negative 2y. So minus 2y goes up there. We take minus or negative 2y times y plus 2, negative 2y squared minus 4y. And we're going to subtract that from what's up above. Change it to addition of the opposite. I get 0y squared. 0y plus 4y is 4y. Bring down the next term. Inside divided by outside. 4y divided by y is 4, so plus 4. And then 4 times y plus 2 is 4y plus 8. And we subtract that from what's up above, change it to addition of the opposite, and we get 0. Well, let's check our work. This times that should equal that. Let's see if it does. I'm going to go to the next screen, and I'm going to take y plus 2 times y squared minus 2y plus 4. Okay, so I'm taking the quotient times the divisor, and I should get the dividend. Let's see what happens. Y cubed minus 2y squared plus 4y plus 2y squared minus 4y plus 8. Well, these terms cancel, those terms cancel, and sure enough, we get y cubed plus 8. So the answer is correct. All righty, let's see here. Let's say we've got this situation. We've got 3y cubed minus 4y squared plus 2y plus 3, all divided by y plus 3. So outside, I'm going to have y plus 3. Inside, I've got y cubed, y squared, y, and no y at all. So there's no missing terms in this problem. It's just got a lot of terms. 3y cubed divided by y, 3y cubed divided by y is 3y squared. So then we take 3y squared times y plus 3, which is 3y cubed plus 9y squared. We subtract that from what's up above, change it to addition of the opposite. 3y cubed plus negative 3y cubed is no y cubed. Negative 4y squared plus negative 9y squared is negative 13y squared. Bring down the next term, the 2y. Start over. Leading term inside divided by leading term outside. Negative 13y squared divided by y is negative 13y. So minus 13y goes there. Negative 13y times y plus 3, negative 13y squared minus 39y, negative, negative 13y squared minus 39y. And we're going to subtract that from what's up above, change it to addition of the opposite. Negative 13y squared plus 13y squared is 0. 2y plus 39y would be what? 41y, and then plus 3. Okay. But then we're going to take inside divided by outside. 41y divided by y is plus 41. We take 41 times y plus 3. We get 41y plus 123. We subtract that from what's up above. Change it to addition of the opposite, we get 0y and minus 120. So all of this plus negative 120 over y plus 3. Okay. Any questions about that? Well, I felt like I was in a race. You probably did too. But we made it through. So that's chapter 5. So tomorrow we'll take a look at chapter 8. I will be back this afternoon at 1:15 if you have any further questions. Otherwise, have a great day, and I will see you tomorrow. Let's see here. Stop the recording.